Now we will discuss techniques for finding derivatives. We have defined the derivative of the function at x as the limit of the expression here as h approaches 0, provided that this limit exists. Now we have used this definition here and have come up with several formulas that we can use as we differentiate functions. Now before we proceed, let's look at other notations that we can use for derivatives of function. So we have this f prime of x as 1. We could also just use y prime, or this notation here which read as the derivative of y with respect to x. And we have this operator here, d, derivative with respect to x of the function f of x. All of these notations here represent the derivative of the function at x. Our first formula is the constant rule function. If a function is a constant, its derivative is equal to 0. So we say that y prime is equal to 0 or dy dx is equal to 0. So suppose we have f of x equal to 10 pi squared. Pi is a constant, approximately equal to 3.14. So 10 pi squared is just a constant number. So its derivative is just equal to 0. Now for this second one, if f of x is equal to negative 5e, e is an Euler's number, approximately equal to 2.71, and negative 5 times that Euler's number is still a constant. So therefore its derivative is equal to 0. The next rule is called the power rule. If a function can be expressed as x to the n, where n is a real number and x here is a variable, then the derivative with respect to x of x to the n is just equal to n x to the n minus 1. So the rule is you can take the power here, bring it down as a coefficient of x, and then subtract 1 from the exponents. So therefore you have n x to the n minus 1 as your rule for the derivative of x to the n. Now applying that formula to the example here, if we have f of x equal to x to the 5th, find the derivative of f with respect to x. So let's apply the formula. The formula is we take the power, so 5, and then copy x, and then subtract 1 from the exponent here. So 5 minus 1, which is 4. So this is just equal to 5x to the 4th. For the second example, we want to find the derivative of f if f of x is equal to 1 over x to the 5th. Now, how can we use the formula here if the variable is in the denominator? So now using the loss of exponent, we can recall that if we have 1 over x to the n, where n is a real number, this is just equal to x to the negative n. So that means we have to rewrite first our f of x as x. So, and then if we're going to put this on top, we will negate the power here. So 1 over x to the 5th can be rewritten as x to the negative 5. Then this expression now is of this form. Therefore, we can use the power rule to differentiate the function. So we have f prime of x is equal to, now you take the power, you take negative 5, you bring it down. So you have negative 5, and then you copy x. So you have x, And then you subtract 1 from the exponent here. So negative 5 minus 1. So this is equal to negative 5 x to the negative 6. You can leave your answer like this and input it in MyMathLab as is. Now for the third example, if you want to find the derivative of the function here with respect to x, and you want to use the power rule, you first have to rewrite this in exponential form. So to rewrite this in exponential form, we recall the following formula. The nth root of x to the m is equal to x to the m minus n. So the power inside the square root is in the exponent, and the index of the radical expression here will be your denominator. So that means that f of x in this example here can be rewritten as x to the 3 over 4. So after we have applied this formula, we're now able to write our function, this function, in exponential form. And then we can now use the formula here. So therefore, the derivative of this function here with respect to x is equal to, so the formula is you copy the exponent here and bring it down. So you have 3 over 4. Then you multiply that to x, so you copy x here. And then you subtract 1 from the exponent. Then you simplify it. So you have 3/4. And then you have 3/4 minus 1 is negative 1/4. You may input your answer like this in your homework. Now the next formula that we can use is the constant multiple property. Constant multiple property states that if you have a function that is a constant multiple of another function in x and you want to differentiate your function with respect to x, all you need to do is copy the constant and differentiate the function. And we can use that with the formula that we just have for power rule. So for instance, if our function is of the form k, constant k times x to the n, then the general power rule will then be f prime of x is equal to copy the constant k and then use the power rule here. So you have n times x to the n minus 1. Now let's apply this property here to the given function here to find the derivative of the function with respect to x. So to do that, if our function f of x is equal to 12x to the 4th, x prime, f prime of x is equal to 12. So you copy 12. And then you bring down 4. That means you multiply it to 12. So times 4. Copy x, and then subtract 1 from 4. 4 minus 1. This is equal to 48x cubed. Let's consider the following example. Let's use the constant multiple rule for power rule. So for letter A, if f of x is equal to 4x to the 5th, its derivative is just equal to 4 times 5 times x to the, subtract 1 from 5. 5 minus 1. Simplify it, that's equal to 20x to the 4th. So the derivative is 20x to the 4th. Now let's find the derivative of y with respect to t for y equal to t to the 4th over 12. Now to apply the constant multiple property, we have to recognize that this expression here is also the same as 1 over 12 times t to the fourth. Then we can use power rule in here to differentiate this with respect to t. So therefore y prime is equal to, copy the constant, 1 over 12 times the derivative of t to the fourth is 4. You bring down the power here and then copy the variable t and subtract 1 from 4. So 4 minus 1. And then you simplify. 1 over 12 times 4 is just 1/3. So you can cancel 4 because 4 is a common factor for 12 and 4. So you have 12 divided by 4 is 3. And therefore, this is equal to 1/3 t to the third power. 4 minus 1 is 3. Now for the third function, before we can differentiate this, we will have to rewrite our y first as 1/3 x to the negative 3. So you have to bring this expression here in the numerator so you can use the power rule. Then, after you've rewritten this as this, you can now find the derivative using the constant multiple property. So you copy 1/3 and then multiply that by the power of x, which is negative 3 times x, copy x, and subtract 1 from the exponent here. Negative 3 minus 1. And then you simplify it. So this is equal to 1/3 times negative 3 is negative 1 times x to the negative 4. Negative 3 minus 1 is negative 4. And this is equal to negative 1 over x to the fourth. Now to differentiate this, we will have to rewrite this first so we can use the power rule. Again, we will use the formula for the nth root of x to the m, and this is equal to x to the m over n. So that means that, and since this one is also in the denominator, you have to bring this up. That means you could also use this property here, x to the n, 1 over x to the n is equal to x to the negative n. So applying these two properties here, we can rewrite this as 0.9 x to the negative 1/3. Then we find the derivative with respect to x of the expression here. Now, using the constant multiple property, we copy this exponent here and multiply it to the constant here. So you have 0.9 times negative 1/3 times x to the negative 1/3 minus 1. That's the derivative. Then you go ahead and simplify it. Now multiplying this to 0.9 times negative 1/3 is the same as 0.9 divided by 3, and that is equal to negative 0.3 x to the negative 1/3 minus 1 is negative 4 over 3. You can leave your answer like that, or you could also write this in this form, which is not really necessary.